Hello friends, in this video tutorial let us see the algorithm of sequence clustering for data mining in SSAS. So for the purpose of this video tutorial let us go and create a new project. Now let us name this project as SSAS data mining 6, right? Let us create a new connection, that is data source to adventure data works DW, so it is pointing to the right database. So let's click next, let's use service account, finish. Let's create a new DSV. Now let us use the same two views that we have used in our last example, that is the view related to orders and the line items. Next, let's call it as DSV, finish. Now as these are views, so there can't be foreign key relationship between views, right? So let us create a logical relationship between these views. This is orders table, this is line items table. So let us create the logical relationship. Now let's go and create a new mining structure. So let's go and select sequence clustering. Now when is sequence clustering used? Generally sequence clustering is used to form clusters where the sequencing of events is useful or is important. For example, let's say if we are analyzing data of sales from a website, okay, that is web-based sales. Now in the website, the sequence of the web pages visited by the customer is important. So the sequence in which the customer bought things on over the website, the sequence of pages through which the user traversed and kept on buying things, it is important for us. Okay, so that's the way in which we can restructure the website, okay, or its flow, content flow. So in such scenarios generally the sequence clustering is useful. That is the scenarios in which we want to, let's say, study the sequence of sales. Okay, we are not only interested in the items which have been purchased, but the sequence in which the items have been purchased, right? If we are interested in that also, then sequence clustering can be used. Let's click next. Next, orders is our main table and line items is our supporting table, that is nested table, right? Detail table, correct? Now over here order is the key. Okay, now over here in this example the line number represents the sequence in which the items have been bought. Okay, the model items have been bought in the order of line number, so line number will form part of the key. Okay, so it is also part of the key. Also, what is acting as an input along with the sequence in which the things have been bought, that is line number, along with that the actual name of the products that have been bought is also an input, right? And also the name of the products is the thing that we want to predict. Okay, so things have been configured in this. Now this is correct. Order number is key, line number is representing the sequence for the key, and model is a discrete value which we want to predict also, right? Let's use all the data. Let's not keep any data for testing purpose, right? So we don't have any test data. We are using the whole data set, right? Let's call this as mining structure, and let's call this as sequence clustering, right? Okay, so our mining model is now prepared. So let's go to database. We can see that there is no database with the name SSAS data mining 6, correct? So let's copy the name. Let's go to deployment properties. We can see that the new database that will be created with the name of SSAS data mining 6, right? So let's provide the server name, right? Okay, now we can deploy. So deployment and processing has succeeded. So let's close everything. Let's go to database. Let's refresh. Let's see that things have come to database. Yes. Mining structure also we can see sequence clustering, right? So let's go. Now we can go and go through our mining model viewer, okay, to analyze the data. Okay. So as we can see, it is quite similar to the Microsoft clustering algorithm. Okay, so this sequence clustering also forms clusters, but basically it forms clusters based on the sequence of the data, right? Or in this case, it is forming sequence of the products which have been purchased, right? So we can see more than 10 clusters, in fact 15 clusters have been created. Okay, so this is for the, this shading is for the whole population. If we want, we can have shading for a particular product also. Let's say sports 100, right? Or let's say mountain tire, right? So it's only present, ML mountain tire is only present in 13 and 2, right? Cluster number 13 and 2, right? So in this way we can see data product wise also, right? So LL road tire is present mostly in cluster number 3. Okay, so in this way also we can analyze the data among the clusters which has been distributed in the clusters. Okay, so now if you want to study profile of a particular cluster, let's say we want to study profile of cluster number 3, then how can we do that? We go to cluster profiles, we go over here, right? Every column is representing a cluster, and we can go over here. This is cluster 3, and then in cluster 3 we can analyze the data further. Let's go to cluster characteristics. So this is for the whole population. So it shows that model sports 100 is the one having maximum sales, right? It is having maximum probability. So if you want to go to cluster 3, then mountain 200 is the starting point, right? LL road tire is also present, right? So in this way we can analyze the further sequence of transactions in the cluster also, right? The cluster discrimination is similar to the diagram or the chart that we had seen as part of clustering, right? Over here we can compare which all attributes are favoring which cluster, okay, or the complement of the cluster, okay, right? And this is very important, and this is new for the cluster sequencing, right? So sequence clustering. So over here, if we let's analyze cluster number 3, okay, so we can understand that generally after cycling cap there is 92% probability of person buying water bottle. Okay, after buying road bottle cage there is 99% probability that the person buys water bottle. Okay, after LL road tire, right, generally there is 62% probability that person buys patch kit, and after patch kit there is 98% probability that the customer doesn't buy anything further. Okay, so this symbol is for AND. Okay, so there is 98% probability that customer doesn't buy anything. So in this way we can analyze the exact sequence in which customer is buying different products using the help of state transitions diagram. So this is very helpful and very important for as far as sequence clustering is concerned. So I hope friends this video tutorial is useful to you. Thank you.